Hey there, everyone. Welcome to the online learning of pre-calculus. Now, I haven't heard from a lot of you much yet, and that's totally fine. So I assume things are going well. And for those of you who it is going well for, great job. I mean, actually, on the work you've been doing so far, you've been overall been doing really, really well. So really good work on all this work you're doing. I'm really encouraged to see how well it's going. If you are having any trouble, whether just accessing the assignments in general or with Khan Academy or with the problems, just let me know. I'm here to help. And I mean, obviously, you're welcome to do these next few weeks on your own. That's fine. But you are kind of paying the school to have me as a resource, and I want to be a resource to you. So let me know how I can help you. I'm here to walk with you every step of the way. If you'd like me to just jump in and walk through a problem with you that you're currently working on, or if you'd like me to do something else, or just like tutor you in a whole topic, that's totally fine. I'm here to help you in any way you'd like me, or I'm here to be a resource. So that's it. What I like to do in videos like these is really just show the problems that seem to be giving us the most trouble on the work, and then walk through the process of how to actually do those. Right now I'm using OneNote, and if you haven't seen the OneNote notebook yet, the link to it is in the whiteboard. On the link to this whiteboard thing is accessible for yourself in RenWeb. So feel free to reference this notebook at any time. I'm gonna try to keep it updated with tools and strategies and solutions for the most difficult problems that we are working with. But without further ado, let's go ahead and look at this first set of problems that we were working with. It says simplify negative roots and the powers of imaginary units. Now, really, before we really get into the problems themselves, let's just refresh our minds one more time on what an imaginary number is. So an imaginary number is this. It comes out of the concept. The imaginary number comes out of the concept that we really have a lot of trouble finding the square root of negative numbers. We don't know how to do that well. Because think about it, if we have this, say for example, this square root of a negative 49, we have this question, because a square root is a question. A square root is somehow the square root of say 9 in general. It asks a question. It says, what is the number that I can multiply by itself to get the number inside? So what number times itself equals 9? And you say, well, 3 times itself equals 9. You could say 3 times itself equals 9. But you could also say that negative 3 times itself equals 9. So you could say this is 3 or negative 3. Because negative 3 times negative 3 is 9, and 3 times 3 is 9. So we're dealing with square roots. It's really just asking a question, what number times itself equals the number inside? Now, if we've got the square root of negative 49, we run into this really weird problem. And it says, well, what times itself is negative 49? You could say, well, maybe you could say it's negative 7 and 7. But if you did negative 7 times 7, well, that would equal negative 49. But if you did negative 7 times the problem with this is that this isn't the same number. It has to be the same number. You're going to multiply it by itself. Negative 7 isn't 7, so you're not multiplying it by itself. You could say, well, maybe what if we did like negative 7 times negative 7? Maybe that would equal 49, negative 49. But that's actually positive 49 because a negative times a negative is a positive. So like down here with the square root of 9, we said 3 times 3 is 9. So that checks out. And negative 3 times negative 3 equals 9. So that checks out. But you can say what times, or up here we're saying what times what equals 49. We're saying what times what equals negative 49. And the problem is we just don't have a number for that. That doesn't really make much sense because no number times itself is a negative number. And so what we decided to do is we said, okay, let's find a way around this. Let's define some number to help us out here. We can say, well, we don't know what the square root of negative 49 is, but we do know what the square root of 49 is. We know that the square root of 49 equals plus or minus 7, right? Yeah, the square root of 49 equals plus or minus 7. Okay, but that's the square root of negative 49. What that's the square root of 49 times a negative 1. Or put another way, we could say this is the square root of 49 times the square root of -1. Okay, so that's a little more reasonable. We can say this is then the 7 times the square root of -1. So that's a kind of way to skirt around the problem. And we could say, well, instead of saying negative, instead of trying to work with this negative number, we can actually take the negative out, this -1 out, and then work from there. And so we do this a bit. We do this a lot, in fact. And so we said, this is going to happen so often. We're going to use this so much. Let's just take a letter of the alphabet and say that is now equal to the square root of -1. And that's what we did. So we said, let's say an imaginary number. We'll call that I. And we're going to make this new letter called I. And we're going to make that equal. We're going to say that equals now the square root of -1. So whenever we have a problem that's really tough, like what's the square root of -49, we'll just take out that square root of -1 and call it I. So 7 times the square root of -1, we can say the square root of -1, that's I. So we'll say this is 7I. I hope that wasn't too confusing. 7 times an I, which is 7I. If you have more questions about that, again, feel free, please tell me, let me know, and I can help walk you through it more thoroughly and more slowly. So the answer to this would be the plus or minus the square root of -49 would be plus or minus 7I, and that would be our answer. Okay. That brings us, that's the first set of problems that we had to do. The other set of problems that kind of gave us a little bit of trouble here and there was this a problem like this. Which of the following is equivalent to the complex number I equals I to the 20th power? Now, before I get too far into this, let's make sure I box this out. That the imaginary unit is I, and I equals the square root of -1. If you can get the idea that I equals the square root of -1, everything else can kind of follow. So let's see a couple of different properties about this square root of -1, this I. If we have I, we know that's the square root of -1. Before we get to the I to the 20th power, let's try to think about what other different powers of I are. Let's say we want to do I squared. Well, that would be the square root of -1 squared, right? That'd be square root of -1 squared, yeah? So square root of -1 squared, you take a number, you square root it, and you square it again. So that's just itself. The square root and the square just cancel. So that gives us -1. Cool. All right. So that's I squared. And then we have, let's see what happens if we do I cubed. Well, that's a little trickier. So we could say the square root of -1 cubed. That's a little confusing. What if we tried I squared times I? That might be more helpful. What is I squared times I? Because I squared times I, that you add the exponents, I to the 2 times I to the first, add those exponents, that gives you I cubed. Then we know what I squared is. I squared is -1. So that's -1 times I. Well, -1 times I, that's just -I. Okay. And how about if we try I to the 4th? Let's do that same process. I to the 4th equals, let's see, I cubed times I. And it's because I cubed, I to the 3rd times I to the 1st, you add the exponents I to the 4th. Okay, I cubed is just -I. Well, -I times I would equal -I squared. -I squared, we know, or just I squared, we know, is just -1. So that gives us I squared is -1. So we say this is -1, which is 1. Interesting. Okay, so all this together, that means that I to the 4th is 1. So if we went to I to the 5th, let's do one more. We'll say that is I to the 4th times I, because 4 plus 1 is 5. And see, we know that I to the 4th is 1, so it gives us 1 times I, which is I. Okay, great. So, and if I is just square root of -1, which is just I, that's interesting. So I to the 5th equals I. So every single time, what that means, so if I to the 1st if that's I to the first, and we add every time we add 4 to the exponent, we'll go back to I again. So you can kind of see a pattern here. It goes I, then it goes -1, then it goes -I, then 1, then I, and then -1, and then -I, and so on, and so on. But you can see it's a process of 4 steps. So every 4 it repeats, every 4. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so that means you just got to keep counting by 4 to see where it is in the sequence. So it goes I minus 1 minus I 1, and so that's 1, 2, 3, 4. If by the time we get to 20, we'd have, let's see, 1, 2, 3, 4, 4, 8, 12, 16. If by the time we get to 20, it's 17, 18, 19, 20. So if you do it over and over and over again, you would get, let's see, at 17 we have I, at 18 we have -1, at 19 we have -I, and at 20 we have 1. So we keep that process, we get that process all the way up by 20, we get back to 1. So that means that I to the 20th power, I to the 20th equals 1. Cool. And that's it. That's all we have to know. But it might be helpful just for a table to keep as a reference that I to the first is I squared is -1, I cubed is minus I, and I to the fourth is 1. And it keeps going through that cycle over and over and over again. Cool?